Hello and welcome. I'm going to be covering today a conversion of a 2003 EasyGo TXT series cart from sealed lead acid to lithium iron phosphate batteries. I did the conversion on this cart about 6 weeks ago and it was successful. I've done a total of about 50 to 70 miles on this cart with these new batteries in, and I've done about 5 half-depth discharges, so letting it go down to 50% discharge and then recharging completely without any issues at all so far. So I wanted to go ahead and cover this process, show you what I did, and hopefully provide some insight into how you can do this successfully. If you're taking on this project, I just want to cover some safety items first. Obviously, this is an electrical system overhaul, and so you have the possibility of electrocuting yourself. And additionally, when you're pulling lead acid batteries, the acid in them has the opportunity to spill out. So it's just important that you take appropriate safety precautions. And if you don't think that you understand how to handle those items safely, then you may want to consider having someone else do the job for you. But if you feel like you're comfortable with that, then I'd recommend trying to do this potentially yourself. As far as my qualifications here, I'm not a golf cart technician. I'm just a regular guy who has some engineering experience, a couple engineering degrees, and I've worked in engineering for about 12 years now. So I have some general idea of like the things we need to do here, but I'm not a technician. So I'm going to be kind of coming at this from the perspective of a person who has a moderate amount of knowledge, but not excessive. And so hopefully this will help catch you up as well if you're not a technician yourself. Major considerations in this project. First of all, is cost. There are several options out there, ranging from very expensive. For example, Dakota Lithium is charging anywhere from about $1,700 to $3,000 for drop-in ready battery sets, and those are labeled as golf cart replacement batteries. If you look at the specs on those, they definitely have the capabilities of doing that, but the cost is kind of high. On the opposite end of the spectrum, there are some very inexpensive batteries that are under $300 each. So a set of batteries for a 36 volt golf cart would probably be $800 to $900. And some of those less expensive options are not really capable, and I'll talk more about that in a minute. So what we're kind of dealing with here is trying to look at options that are in that middle ground where you actually have to do a little bit of math and look at the specs of your cart and look at the specs of the batteries. But in certain conditions, and this one we'll see it was met, that you can save on cost considerably over these high-end batteries like Dakota. The second part that was important for this was warranty. Dakota Lithium's got warranties on the order of 8 or 10 years, and that seems to be like full scale. They'll provide replacements during that timeline, but again, they're very expensive. Now, looking at some of these less expensive batteries, the warranty situation is not as clear. For example, I looked at swapping these for or doing an EnjoyBot set of batteries, and the prices on those have gone up a little bit, so that was part of the consideration. But the other part is that even though they say they had a 10-year warranty, if you look at the actual fine print, it's really only a 3-year warranty that they provide replacement. And the other 7 years after that is just technical support. So that seemed a little shady to me. And there are some other battery options that I found on Amazon that will say 5 years, but then if you look at the fine print, if you use them in a golf cart or a boat or anything that's power equipment like that, they only actually will cover for 1 year. But there was one brand that I found called OGRPHY that has an actual 5-year warranty, they claim, that will actually do replacement if the batteries fail. And as we'll see, that's the brand of battery that I ended up going with during this project. And part of that explanation as well is when it comes to support and responsiveness, I tried to reach out to some different companies to ask questions. Particularly the one I tried to work with most was EnjoyBot originally, because I had seen several conversion videos where people would use those batteries. But response times were sometimes multiple weeks, and then I even got different answers from different people. So if I went through the chat, I would get one answer to some questions, and if I sent an email that wasn't getting a response, and I later got a response, I get a different answer. That was kind of concerning. But the company I went with, OGRPHY, had responded to me within a day whenever I had questions about the applicability in this particular cart and asking for some more specs. The big thing here is that whatever battery set you go with, it's got to have the right capabilities. And the big capability that we have to talk about really are twofold. One is surge current capacity of the battery set, and the second is sustainable capacity of the batteries in terms of their ability to provide current. In addition to the fact they need to have sufficient amp hour capacity to be able to get you, where you're going to go. And so let's talk about that a bit. This particular cart has a 1,900 watt motor that's 1.9 kilowatts. And it's a 36 volt battery set. Realistically, it runs closer to 39 to 40 volts, but at the low end, whenever batteries are nearly discharged, it can be closer to 36. If we do the math here, the way that we determine the current that's required under that steady operating condition, we take that power, 1,900 watts, and divide by the voltage. So we do that 1,900 watts divided by 36 volts would be 53 amps continuous just to operate the motor. In addition to that, as you'll see in the following video, I also have a step down converter that takes 36 volts and converts it to 12 volts to feed auxiliary loads such as the headlights. I've got a little cigarette lighter adapter that I use to charge this onboard speaker, and the horn. Those all operate off 12 volt. In actuality, those total loads are something like 100 watts or less, but technically the capability of that converter is 360 watts. But let's just say even we were getting close to the maximum using 300 watts off of that, the total power requirement for this cart would be 2,200 watts. And if we divide that by 36 volts, we would see that 61 amps could potentially be required under steady operating conditions. And additionally, when you talk about surge current, the controller on this cart is 350 amp controller. And that means that the highest current it can provide to the motor, this is like when we're taking off or maybe like climbing a really steep hill, could be theoretically 350 amps. I will say I've, in this process, installed a meter that shows me the current that's actually passing. And I've never seen anything close to that. Highest I've seen is spikes of about 120 amps. But be that as it may, let's say that we determine we really need to be able to handle that 350 amp capacity. The battery management systems on these batteries, the ones that are kind of in this category we're talking about, these mid-range batteries that should be able to potentially handle, meet the need, but are not extraordinarily expensive, all seem to have a 100 amp battery management system under continuous operating conditions. So it should be able to sustainably handle 100 amps. That meets the requirement for the continuous operation of this cart. What's more difficult to determine is the capability to provide this surge current. I contacted OGRPHY to ask about this, and they said that their batteries could handle 400 amp surge for about 1 second. And the way that these systems operate, these battery management systems, kind of like fuses, in that if you have a high current, it can handle it for a short period of time. And the closer you get down to this this long duration current that it can handle, the longer it can handle it. So 350 amps, it should be able to handle for a second or two. And you say 200 amps should be able to handle for several seconds, and 100 amps it should be able to handle indefinitely. And so I picked these batteries based on the fact that, it met all the requirements really for this cart, and the price was good. You can go and look for yourself. I'll provide links at the bottom of this video to everything that I use in this process, but the price was good and it seemed to meet the capability. So I did the installation and it's worked out really well. Haven't had any issues at all. The batteries are significantly lighter. The cart actually goes about 1 mile an hour to 2 miles an hour faster than it did before. We have a little speed sign in the neighborhood, and I used to get about 13 miles an hour on the cart by myself with the lead acid batteries, and now I'll hit 15 typically. And I think that's mostly just due to weight reduction, honestly. The actual operation of the motor shouldn't be any different, but it shaved a couple 100 pounds off by doing the battery swap. So now what you'll see follow is the process going from pulling the batteries, the old batteries, dropping in a drop-in tray, putting in the new batteries and configuring them and strapping them down and taping them in and things like that. And then ultimately you'll see the final outcome of this, the final configuration with all the equipment installed. And I hope this is helpful for you. Okay, so a couple of additional clarifications I wanted to add before we get going into the conversion process. The 120 amp surge current that I discussed before, it's just during takeoff, and I've only even seen it that high a few times. Doing things like climbing hills, I typically don't see more than about 70 amps, and even though the theoretical steady state current should be around 53 amps, once I'm actually at speed and I've hit the maximum RPM that the motor is governed to, it actually is only closer to 40 amps continuous. So really these batteries are well within that capability. Let's talk about range real quick. The 40 amp current, if we're doing that for the total amount of amp hours that these batteries can handle, that'd be for 100 amp hours, should mean that we could run this cart for about 2.5 hours. These lithium batteries can be fully discharged. So we should be able to use the whole 100 amp hour capacity. That would put us 2.5 hours of operating time at about 14 miles an hour, should put us well over 30-mile range on full discharge. And so for me, I only do about half depth of discharge, which would put me about half that, 15 plus miles on a charge. The comparison for amp hour capacity on a lead acid battery compared to one of these lithium batteries, again, lithium batteries are supposed to be able to fully discharge and to be usable throughout that entire range. For lead acid, it's only about half of the capacity can be discharged before the voltage drops too low, from what I understand from doing some reading. And so even though lead acid batteries typically will have a higher amp hour capacity shown on the label, ones that came out of this were about 200 amp hours, maybe a little more. But if only half is usable, that means that this 100 amp hour lithium set should be equivalent to the usable capacity on a lead acid battery set. There are six 6-volt batteries in a standard lead acid set. And these batteries that we're dealing with here, and once we're talking about the ones I'm using in this situation, and most of the equivalent ones, are 12-volt batteries. So you actually only need 3 of them. That shouldn't really affect much other than the fact that obviously they don't have the same form factor, and so you will have to organize them. I'll go through that process here momentarily. And one additional thing is that when I talked earlier about the capacity of the BMS system, the battery management system, I said it was typically 100 amps continuous operating current. That's for the 100 amp hour batteries. And I think that's just based on the number of cells that are in these batteries. You know, that's the capability. If you were to get 50 amp hour batteries, most of those have a 50 amp capacity. So that's part of what limited our ability to have any say here in which batteries we're getting used. A 50 amp hour battery just doesn't have the current capacity to actually drive one of these carts continuously and it'd be a guarantee. Now, on the other hand, you could go higher and get 200 amp hour batteries. But first of all, I don't think they would actually fit in here. Or even if you tried to get 600 amp hour batteries and do 3 in series and parallel with another set of 3 in series, I don't think they would actually fit. It doesn't seem to me like that would be possible. So if you're trying to get a higher capacity or you're trying to have an even higher current capability, which I don't think is necessary, it certainly wasn't here. But if you're trying to do that, you may have some additional considerations here. But what I was saying before, as far as those 100 amp hour batteries, those all that are kind of in this category seem to have 100 amp battery management system limitation. These OGRPHY batteries have done great though, so I just wanted to provide that extra bit of insight before we jump into the actual conversion process. All right, so just looking in at the battery well, here we have the 6 lead acid batteries that are currently in there. There are some things you have to do as part of this conversion as well that I've already done. One of which is not optional. That is, you need to get a battery charger that is capable of charging lithium batteries. The one I'm using, we can see here, is this Noco Genius Gen Pro 10 times 3. That means it's 10 amps into 3 banks. And you can see the selector buttons below. The lead acid batteries is just one of the options kind of at the bottom end, but also it can seal, or it can charge rather, gel batteries, and it can charge lithium batteries as well. Now the reason I went ahead and installed this ahead of time is that there was a question as to whether or not the reason these batteries were underperforming was because of them being charged as a big bank. So with a normal charger, what you're doing is applying 36 volts across the entire battery set. But whenever this was originally set up, the 12 volt loads were being pulled off of 2 batteries, and that means that those 2 batteries were getting drained faster than the rest. And so part of the question here was whether or not these batteries were just starting to fail because of differential discharge, 2 of them being really undercharged and the rest of them being overcharged. So I went ahead and got this charger so that I could charge them in 3 sets of 2. That is, these 2 batteries are being charged at 12 volts, and then those 2 are being charged at 12 volts, and these 2 together are being charged at 12 volts to help deal with this charge differential problem. And it seemed to help some, but still these batteries are underperforming at this point, so it's still time to do the job. Also, as far as talking about this, what I'm about to say is optional but recommended. That is, rather than pulling 12 volts off of 2 batteries and using that for your 12 volt loads like your horn and your lights and things like that, what I would recommend doing is getting a step-down converter. That's what this is, a step-down converter. It takes 36 volts across the entire battery set and then steps it down to 12 volts to feed your 12 volt loads. So the way I have it here, it's wired across the entire bank of batteries, and then this yellow wire goes around to a fuse box. That fuse box is what's feeding all of my 12 volt loads, my cigarette lighter adapter, which is shown there, and the headlights on the front and things like that. So anyway, what we're going to do now, let me talk about the plan. Since that charger is already installed and is available to charge the new batteries, what we have to do here is disconnect all of the wiring, pull all 6 of these batteries out. And the way that we pull those batteries out is to take off the center bracket. You can see there are a couple of bolts here, and we need to take the nuts off of those, pull the center bracket out after we've removed all the wiring. And then these need to get pulled out. I've got a little battery removing handle. I think you can see it over here in the corner. Yeah, right there, that little battery strap. If you don't have one of those straps, you'll definitely want one of those to help get these batteries out. Once all the batteries are removed, what's going to be left behind is an open bottom battery well. So what I do have is a plastic drop-in tray to fill in that opening so that I have more flexibility for putting in the new batteries, because the new batteries don't fit this exact same form factor. So I'm going to have to put that battery tray in so I can put in the new batteries and then get them arranged the way that I like without them just falling through the floor. So that's the general plan. As far as doing the work we're about to do for removing all these wires and pulling this out, just some precautions here. Number 1, you want to make sure that you don't electrocute yourself and you don't start a fire and you don't cause any batteries to explode. So you want to make sure that you do not connect any lead on these batteries to any other lead on the battery set to actually close a loop. And whenever you're removing all the wiring, try to keep track of what went where. So I would take all of your negative leads and maybe zip tie them together. If you feel like they're gonna fall into places, you'll forget them. Same for the positive leads. Once you remove them, kind of maybe zip tie those together or use some tape or something to hold them together so that you don't lose them. And then once you've connected the positive and negative leads, you're going to go around and disconnect all the jumpers that go between all the batteries. And once all those are out of the way, then that's the time to then pull the center bracket and begin pulling all these batteries out. And once I get done with that process, we'll hop back in and see some of the intermediate steps. Okay, so we're at a point now where the batteries have been removed. I did basically exactly what I described. Zip tie the positive leads together, zip tie the negative leads together to keep them grouped. Removed the negative leads, removed the positive leads, removed all the individual intermediate jumpers, and grouped all of my charging cables over there kind of away. And as far as the actual jumpers and everything, just pulled all those off. And as far as the order, once those were off, these front 3 batteries, the ones that are nearest to the front passengers, got to come out first. So it doesn't really matter what order you pull those in. And then after that, you don't have to take this whole cover off. You just got to lift it up. And once you lift it up and the front ones are out, you have access to pull out the back ones. Now, another thing that I did here was before I got started, not full coverage there because of the rear wheels, but I put some cardboard underneath just in case any acid leaked or if there's some corrosion. Though honestly, there was no issue with that. And I'm actually pleasantly surprised. The corrosion in here is not that bad. I mean, it certainly could be worse. So I should have no problem dropping in that plastic tray. What I did prior to pulling the batteries out was to stage some large yard bags. So I just opened them up so that I could set these batteries straight down in them. And now the goal is I'm going to bag each of these up and probably even double bag it just to make sure that no acid spills out and they can be kind of handled without extraordinary precaution. Obviously, you don't want to tip them over because you don't want the acid to come out, but I'd like to prevent all of that from happening. Also, if it's not clear by the fact that they are lead batteries, they're heavy. So if you aren't in decent shape, this is a tough task actually. And this is the drop-in battery tray that's going to be going in momentarily. So that battery tray is going to get dropped into this opening, and the 3 lithium batteries are going to be placed in thereafter, and I'll kind of stop in at points moment. All right, stopping back in. This is post battery tray drop in, and we can see it just fits right down in that opening. One thing that we do see here is that those 2 center brackets, those post holders are there. So those are from where the original bolts that came up to hold the battery top bracket in place. Those were mounted to this, and they're still there. I don't have any intention of cutting them out. I think I'm going to be able to work around getting the other batteries put in. So basically, probably 1 battery this way, 1 battery across, and 1 battery down, or something similar. But as I get those batteries unboxed and begin arranging them, I'll stop back in to discuss how that's worked out. Additionally, all of those original lead acid batteries I've double bagged. And just a practical note here, although this makes me feel a lot better about being able to transport them in my vehicle without getting corrosion or acid anywhere, it has made them slick and kind of difficult to wrangle around. But at least I'd feel better about putting these in the back of my car than before. But they were ridiculously heavy. I'm excited about the transition to the lighter batteries once those can be put in. All right, before I keep going too much further, I do want to pull at least the battery out, the new lithium batteries, and show you what they are. These are OGRPHY lithium iron phosphate. Each one's 12 volts. They're 100 amp hours. They'll be wired in series in this cart. Came well packaged and came with some brochures. People have already done unboxings of these batteries, and there's even one video I've seen of a complete teardown, like opening it up. I'm not going to go into any level of depth like that. These are just the point here is for me to demonstrate whether or not they function in a golf cart, and if the manufacturer's estimates are correct and our discussions are correct, then this should be suitable. We'll find out soon enough. As far as the documentation and stuff on these, again, there are other people who've done complete walkthroughs of the exterior and interior of these. Yeah, that's the battery. I'm going to put 3 of them in, and we'll see how we can get them arranged. All right, here's the arrangement that I think is going to work out for this. Got the 3 batteries in. The center bracket that's down there at the bottom is right between these 2 batteries. And the positive end should go there, and we'll chain it positive, negative, positive, negative, positive, negative, and back around to the negative end of the battery, which is approximately where the original negative was. So I shouldn't have to really rerun any wires or anything. The only thing is keeping these in place. So there's going to be a two-part process in this. First of all, I've put these in and see that the slick surface of these slides around on the slick surface on the bottom of this tray. So I'm going to pull these back out and put at least a little bit of 3M two-sided tape on them so that they'll have some adhesion to the bottom and won't slide. And then I've also previously purchased for this project some little straps, and I'm going to try to use these. These are 4 feet long. I'm going to try to use a couple of these to hold those batteries in securely so that they don't move. So between the 3-sided tape and these straps, I think we'll be able to get them secured. Afterwards, I'll again check back in to see how it's. Okay, so what I'm using for the bottoms of these is 3M VHB double-sided tape. If you've not used it before, it really is spectacular. Double-sided tape, I've used it a lot. Actually just finished up my roll doing this project. But the two batteries that were placed side by side and the same orientation, the one that's on the positive end and the negative end, putting the 3M tape like this looks like it'll be the way to get it to actually adhere across the surface. The one that's on the end, the middle battery, needs to have tape that's in this orientation so that it'll actually, stick on some surfaces and be guaranteed to stick there. So now obviously I need to pull this backing off, and then I'm going to drop these in. Okay, then this is after having the batteries effectively installed but not having the leads attached. To be honest, after putting that two-sided tape on the bottom and putting them in, I feel pretty confident that that would have held it, to be honest, but I've added some additional straps. I put one of these black straps around the outside, the entire periphery of the 3 batteries to hold them somewhat together. And then, as you can see in here, I've got a strap that goes across, and it goes all the way underneath the tray, like kind of underneath the golf cart, and back up. And that holds this one, keeps it from moving front and back. And then these two, same thing. It's wrapped around underneath and comes back up this side. I think that between that, there's not much opportunity for it to slide left, right anyway, because the sides of the battery tray are pretty close. They couldn't go very far, and with that 3-sided tape on the bottom and these straps holding it down on that strong 2-sided tape, I feel that this is not going to go anywhere, and it looks like a pretty clean installation. All right, so let's talk about the final configuration. As before, we've got these 3 lithium batteries. Negative end is down here, and that attaches in series to this middle battery, and then that one attaches in series to this final battery. So we're at 36 to 39 volts up here on the positive rail. They're all being charged by this Noco Genius charger, same one I discussed previously. It's in the lithium charging mode. It has 3 separate available banks and at 12 volts each, and so each charger charging set of leads is attached to its own battery. So this one, for example, has got the positive or the negative charging lead there, positive charging lead there, and each battery is configured that way. The actual charger itself is not the way that I have it set up is that it attaches to like a little extension cord, and that extension cord goes to a charging port that is currently installed on the front of this cart. So let's come around here. You can see that this is that charging port. Basically, you just plug an extension cord in there, standard 120 or 110 volt, AC cord, and then that just goes through to the extension cord here, and that plugs into the charger. It's pretty convenient. I don't have to open up the golf cart seat to do any charging. This other port still attached, same as before. So if I were in a situation where I needed to use a regular EasyGo charger, I guess I could. It's not recommended to use the standard lead acid charger, but if I were in a pinch, I still could do it. I may get a plug of some kind to actually plug that hole up because I never use it, but that's how the charging is set up. The batteries themselves are still strapped down in the same way that they were shown in the previous video, and they are still have the adhesive tape on the bottom that's holding them in place. My only sort of mild gripe is that these straps seem to loosen a little bit over time. So what I'm probably going to do is maybe, I don't know, like take the end of the strap and kind of tape it to the actual main body of the strap to keep it from slipping at all. It's not much, and it doesn't really seem to matter. But if I could go back and do this again, I might consider doing like a ratchet strap instead and just not tightening it down very hard. I don't want to break anything, but ratchet strap's not likely to slip. These are working fine. The other thing here is that I actually did install, actually I guess it would be more important to show you this. So this is a battery meter, and it shows not only voltage, but actual capacity. And the way that it actually knows the capacity and the fact that, you know, how much capacity is left is that this is one that uses a shunt to measure the current that is passing through the negative lead. So I go from the negative lead here on the negative end of the battery directly into this, and then off of that I have another lead that connects to all of my negative loads. That includes the actual motor, the negative side of my 12-volt step down. Everything connects there. It's a little bit hokey to be using a just a bolt and a nut to hold all these together, but really all the leads are sandwiched together there. The only reason that I didn't directly attach it onto this end of the shunt is because this Rhenology shunt has got a larger post there than is standard for everything else. So none of my ring terminals would fit on that. I had to get a larger set of a larger ring terminal negative cable, and then basically put all those together with a homemade bus. You can buy actual you know, little bus terminals, but it has not caused me any issues. I mean, it's been working great. Let's see. I think that's really all that needs to be covered here. This actual shunt is, you know, like I said, all the negative side current passes through it. It uses that to determine the current passing through at any time. Gives me current monitoring capability. Also, then, you know, can read how much current's been passed through, and therefore counts down the capacity. So if I were to run it at, you know, 40 amps continuous for an hour, well, then it would subtract, you know, 40 amp hours from my overall existing capacity. And this also allows me to see whenever it's charging what the charging rate is as well. And I can see that it actually has been charging at 10 amps. And then on the positive end, the positive terminal just attaches there, so it can give you the voltage difference between the positive and negative rail. My only sort of gripe in general about not just these batteries, but seemingly all batteries that are of this type is the way that the posts themselves are configured. If you were using a regular golf cart battery, like a sealed lead acid golf cart battery, it works the same as it does in your car, and that in most cases you have an actual post that sticks out of the battery, and then you put your ring terminals on that post, and then you tighten down a nut on top of it, and that is how everything's attached. The way that these work is that there is a, if I were to take one of these little caps off, you could see it better, but it doesn't really matter. You take out, you know, if you take this cap off, what it is there's an actual screw on top. It's larger, and you unscrew it, and the actual battery itself doesn't have a post. It has a terminal with an open screw hole in it, and then the post, basically the post instead is effectively on this end that you've removed, this screw that you've removed, which means that you can't just take your terminals, or rather all of your connections, and just hook the ring terminals over one at a time and make connections one at a time, and then put a nut down on top. Instead, what you have to do is basically hold the screw in one hand, put all your ring terminals onto it, and then while you're kind of holding them all sandwiched together, try to put that screw down into the battery and screw it in there. Obviously not by hand. You would try to use a screwdriver. And what that means is that it's just a little more difficult. You don't get to put terminals on or put wires on one at a time, you kind of have to put them all on all simultaneously. And you look at this end, that's a lot of stuff. I had to stack all those together onto that screw and then stick it down in there and screw it in and make all my connections simultaneously and hope that there were no issues. But it worked out okay. I mean, you can test these one at a time by touching them to that connection on the battery and making sure everything works okay. The only one that I had any issue with, honestly, is that these step-down converters, there's an internal capacitor that will discharge whenever the leads are open. So whenever you reattach it to the battery, that capacitor tries to charge up instantaneously and causes some sparking. So that's the only one that was giving me any sort of scare. And so anytime I had to disconnect and reconnect things, I had to go through that process again of trying to do that as safely as possible. But anyway, that's the final configuration. Getting a little dusty under there at this point. But all that proves, I guess, is that after all these weeks of use and even, kind of being in a use condition now, everything's working great. And it seems to me like this is going to be the long-term configuration. I guess just one more little practical bit here, at least if you're on this cart. So this shunt has to attach up to the actual meter that's shown here in the cart, and that there's a wire that just needs to be passed from the battery well up and underneath. I did it up underneath here, kind of behind the wheel well there, up inside. And then this, you could cut this out, but honestly, at least in this situation where the open radio hole is, I just put some two-sided tape on the back of that meter interface there and just kind of stuck it in there. And you may think at this point that I must work for 3M or something because I love that tape so much, but no, it just seems to work out well. So that's how I mounted that in there. Anyway, that's the final configuration on this cart, and like I said, it's working great. So hopefully this will be informational for you and maybe inspirational to make this conversion, given the fact that you can now do this for about the same as just swapping out your regular lead acid batteries. Leave any comments if you have anything to say, or if you have any questions. I'll try to respond, but I also have several kids and a job, so I can't necessarily respond to everything. But if you have any questions or anything, feel free to respond so I can try to address any questions you might have. All right. Hope this was helpful. See you later.